So 3 things to keep in mind when you're doing particle motion.
Again?
That's the velocity, acceleration, position, all that stuff.
Yes.
If you take the integral of the velocity, that goes backwards.
Yeah.
So it tells you to position. Yeah. So that's what this is saying. That's what 1 is saying. So that is like if we had a picture.
I've learned that math is like when English aren't helping.
And so
Oh.
if I was trying to find the integral from A to B of the velocity, then of course that's the area from A to B under this curve. It'll come back on. Under that curve. And that is going to tell us what position it traveled or what distance it traveled from A to B. Because it's going from position B minus position A. So.
Is your TV bigger than other teachers?
Oh, I think so.
I think so. I feel like it is.
I think we're just closer.
We're closer, yeah.
Okay, number 2. If you are trying to find the distance from A to B, then, like I just told you, that's the net, not distance, I said distance, the integral from A to B of the velocity. Then that's the net distance that you traveled. So that tells us how much distance I traveled. The reason why it's net distance is because we have that same, we'll pretend it's the same. And let's say A is here and B is here.
You're going to subtract the stuff under the...
Right. It would look like that. So it's only the net distance, the final distance that you traveled from point A to point B. It wouldn't be the total distance because it's going to subtract what's under the x-axis. Now, on number 3, if you want to find the total distance, then you have to take the absolute value of V of t. And what does absolute value do to anything that's negative?
Makes it positive.
Makes it positive. So what it would do to this picture is it would take this and it would move it up here. So that your area then would be that blue part, and it would add those, and it would make it a farther distance. It wouldn't be net distance, it'd be total distance.
Yes.
So, for example, we have the velocity of a particle moving along the x-axis, and there's our equation. V of t equals 3t squared plus 6. Mm-hmm. And notice it says it's a non-calculated question.
Active. Why did you say active?
Well, that's how they define it on the AP exam. It's calculator, active, and non-calculator. If the position of the particle at t equals 4 is 72, that means P position at 4 equals 72. So it's written like this, but you got to know that that means that's an initial condition. And we want to know what is the position, so P of t, at 2. So P of 2 is what we're looking for. How are we going to figure that out?
Take the antiderivative of the velocity thing.
Okay, of the velocity, which is 3t squared plus 6 dt.
Yeah, and I got t cubed.
Or we just take it.
Right, but what are the endpoints going to be? 4 to 2?
Oh,
2 to 4. Yeah. Now, the reason why we're using 2 to 4 is because we are given 4 and we're looking for 2. I know, right? So that, of course, ends up being the position of 4 minus P of 2. Okay with me? All right. Now, yes, you're right. On the left, we can do that. 3t squared plus 6. I make that t cubed. Divide by 3. So that's t cubed plus what? 6t. Evaluated from 2 to 4. P of 4, we know. What is it? 72.
So what do we plug in?
2.
Huh?
What do we plug in? We plug in 2.
Well, we plug in 4 and then we subtract 2. We do both. Just like always. So it's going to be 4 cubed plus 6 times 4 minus 2 cubed plus 6 times 2 equals 72 minus P of 2. Are you okay?
Yeah, I did the math.
4 cubed 64 plus 24 is 88?
Yes. Sure.
I guess I could look.
Was it 24
Yep.
plus 64? Yes.
Yes. Plus 20. Oh, no, I already did that. Minus 8 plus 12. 20.
Hey, you're going to be right. You know, you said plus 20.
88 minus 20 is 68. Subtract 72. That's negative 4.
Wow, I thought I did it wrong. So I did it different. I go.
Divided by negative 1. 4 is P of 2. What's wrong, babe?
I don't know, because I also got negative 4, but I didn't do it like that. Did you do it the way I do it? No. Oh, what?
We were almost done.
I just kind of did it in my head.
2 plus
You.
That's,
How did you get 4?
I would put 2 in that. I'm sorry, I did that stupid.
2 and what?
In the position equation. Did I do math wrong?
8 plus 12 is 20.
Literally, I have no clue.
Yeah, you just, yeah. Me either.
Somehow, I got 4.
Yeah, no. Okay, the next one is the total distance from 0 to 7.
We'll take the absolute value.
Yeah, so it's going to be, I'm going to write TD for total distance. Integral from 0 to 7 of the absolute value of 3t squared plus 6 dt. Now, let's think about the graph. Since we don't have a calculator.
Oh, great.
Think about the graph of 3t squared plus 6. What does it look like?
It intersects at 6.
It intersects at 6, yes. What is it?
3?
The line,
Function.
and then it's gonna go up 3 over 1.
Okay, what shape's it going to look like?
A curve.
Dun.
What is that curve?
Is it-
Thank you, a parabola.
It's on first time.
Yeah, it's a parabola. And which way does it point? Up. Where is it crossing the y-axis?
6.
6.
It's gonna be like this.
So, yeah. She's doing this, by the way.
Over here.
It's,
It doesn't cross. It doesn't cross.
yeah, it looks like that.
Cute. Oh, okay.
So it's all positive. So we don't even have to worry about the absolute value part. So we already know what the antiderivative of 3g squared plus 6 is. We did that. It's t cubed plus 6t. And this time we're evaluating from 0 to 7. Are we okay? Yeah. Okay. So 7 cubed plus 6 times 7 minus 0. 343. Ah. Yeah. 385, and it didn't give us units, so I can't say if it's feet or whatever.
Seems like it should be.
Can I
more
write
than-
385 units?
You can write that, yes.
Would they do that?
No.
Or get most ones to write units?
No. Okay, next one is a calculator problem. So
Is that a woo?
yeah, I know, right? Usually calculator problems are harder.
I know many things like instinctively would. I don't think we mentioned. It's like instinct.
The velocity of a particle that is moving along the x-axis is given by this equation, and it says this is a calculator active question.
Because it's just.
So if the position of the particle at t equals 1.5 is 2.551, so how do I write that? P of 1.5 equals 2.551. What is the position when t equals 3.5? So this is like the last problem.
Actually, no.
We're looking for that.
Wait, we could just look it up. couldn't
Look what up.
Put it in the
We
calculator.
We are going to, part of it, but we still have some other stuff we have to do.
Dang.
So it's the antiderivative of what? Or the integral of what?
BT.
Yes.
1.5.
B of t dt from 1.5, yes, to 3.5.
Is that what you're looking for?
Yes.
Yeah.
Equals what's what? Equals what minus what? I should say.
B of 3.5.
P of 3.5
P, whoops.
minus
P of 1.5.
1.5. Okay, good. Now, here's where people mess up all the time. They take way too much time because they want to do it all by hand. I'm happy you can do it by hand. But if it's a calculator problem, flip and use the calculator.
That's what I'm saying.
So otherwise it's going to take you too long and you're going to run out of time. There's a reason that it's a calculator problem. Usually it's to save time.